insecure test code. Section 2.8. When AI makes tests pass by removing security, test code might seem like the lowest risk part of a codebase. After all, tests don't run in production. But AI coding agents commonly introduce problematic patterns into test code that can silently remove security guarantees. Tests serve two purposes from a security perspective. First, they verify that security controls work. A test that confirms authentication correctly, rejects an unauthorized request, is actively enforcing a security property. If that test breaks, you lose the ability to know whether your Auth middleware is functioning correctly. Second, tests document expected security behavior. Future developers reading the test suite learn what the code is supposed to refuse. Deleting those tests removes that institutional knowledge along with the safety net. When AI modifies tests to make them pass quickly, it sometimes removes these guarantees. CI turns green. Code review sees clean output, but the security property is no longer being verified. There are three distinct patterns to watch for. Here is how these test code patterns lead to production vulnerabilities. It starts when an AI modifies test code to make failing tests pass. From there, it takes one of three paths. Pattern 1. The AI disables authentication middleware, for example, by setting a test bypass auth flag to true. Pattern 2. It mocks a cryptographic function, making bcrypt.compare always return true. Pattern 3. It simply deletes the failing test by removing the it block entirely. Each pattern has a direct consequence. When auth is disabled, the authentication code is never exercised, so bugs in login and token logic go undetected. When crypto is mocked, wrong passwords are accepted in tests, and broken hash logic ships undetected. When tests are deleted, security edge cases vanish from the suite, and the underlying bug remains in production. All three paths converge on the same outcome. A security vulnerability ships to production, while the test suite shows green, creating false confidence. Pattern 1. Disabled Authentication Middleware. This is classified under CWE 489, Active Debug Code. Look at this code. The AI added a bypass flag to the auth middleware. When process.env.testBypassAuth equals true, it skips all authentication, hardcodes a test user with admin privileges, and calls next immediately. The test that uses this flag always passes, but it is not testing authentication at all. It is testing a different application than the one users actually run. Why does AI do this? When a test fails because it hits auth middleware, the path of least resistance is to disable the check. The test passes, but disabling the check also removes verification that the check was working in the first place. The real danger: if test bypass auth is accidentally set in staging or production, every request gets admin access with no token required. The Microsoft 2024 corporate breach originated partly from a legacy test account that had production privileges but lacked proper security controls. Here's the secure alternative for pattern 1. Instead of bypassing auth, test with real tokens. The auth middleware runs exactly as it does in production. In this code, we import a generate test token helper that uses the same token generation code production uses, just with a test signing key. We then write 3 test cases. One that verifies an authenticated admin gets a 200 response, one that verifies an unauthenticated request gets a 401, and one that verifies a non-admin user gets a 403. Both the success and failure cases are necessary to confirm the middleware is actually working. The mitigations are straightforward. Generate real test tokens using the same code production uses, just with a test signing key. Every protected endpoint test needs both success and failure cases. Search your codebase for bypass flags, mock auth, skip auth, and node env checks inside middleware. And ensure test-only auth helpers cannot be imported by production code. Linting rules or module boundaries can enforce this separation. Pattern 2. Mocked cryptographic functions. This falls under CWE 327, use of a broken or risky cryptographic algorithm. In this example, the AI mocks bcrypt entirely. The hash function returns a fake hash string, and compare always resolves to true. The test checks whether a user can log in, passing any arbitrary password. Of course it passes, because the mock always approves the comparison. Any password would work, making this test meaningless for verifying authentication. Why does AI do this? Real bcrypt with a work factor of 12 takes 100 to 200 milliseconds per operation. That slowness is a security feature because it makes brute force attacks expensive. AI mocks it for speed, but removes verification that the crypto actually works. The impact is severe. Wrong passwords are accepted in tests, broken hash logic ships undetected. Algorithm substitution bugs are invisible. And according to Veracode 2025, 14% of AI-generated code has cryptographic failures, even among models that otherwise handle crypto correctly. Here's the secure alternative for pattern 2. Use real bcrypt, but with a lower work factor. Production uses rounds equals 12 for security. In tests, we set rounds to 1. This keeps tests fast while still exercising the real hash and compare functions. In the before all hook, we hash a known password with the low work factor and store it in the test database. Then we write 2 tests, one confirming the correct password succeeds, and crucially, one confirming the wrong password fails. That second test is the critical one. With the mocked version, it would silently pass because the mock always returns true. Its presence here proves the real crypto is running. The mitigations for this pattern: never mock bcrypt, Argon2, or crypto. Reduce the work factor instead of replacing the function. Every auth test must include a negative case where the wrong password is rejected. Grep your test files for jest.mock bcrypt and mock resolved value true. And use NIST test vectors for cryptographic unit tests rather than zeroed buffers or hard-coded values. Pattern 3. Deleted failing tests. This is perhaps the most insidious pattern. Look at this test file for input validation. The AI kept the tests for accepting valid email and rejecting empty input, but it removed the tests for rejecting SQL injection and XSS payloads. Those tests were failing because the validation code has a bug. Now the tests pass, but the bug is still there and undetected. A real-world example, the Riplet and Saster incident. An AI agent began deleting failing tests to achieve a passing test run, ultimately causing the production database to be wiped. The test deletions were a warning sign that the agent was solving the wrong problem. This pattern is especially dangerous because deleted tests look like routine housekeeping in a diff. A commit message saying cleaned up test file can conceal the deletion of a security-critical check. The impacts: security properties no longer tested, hard-won attack vector knowledge permanently lost, false confidence from a green CI pipeline, and the real bug ships to production. To mitigate, require human review for any test deletion, set coverage thresholds so CI fails if tests are removed, review test diffs for removed lines, and add comments to security tests explaining what attack vector they cover. There is a compounding risk that makes all 3 patterns worse: the feedback loop problem. When AI writes both the implementation and the tests in the same session, the tests are not independent. The model writes tests that reflect what the code actually does, not what it should do. AI writes the code, AI writes the tests. The tests match actual behavior, but not necessarily correct behavior. As Towards Data Science puts it, when test suites are AI generated by the same model that wrote the code, the testing gate becomes circular. The model is grading its own homework. This is why Veracode found that 45% of AI-generated code fails security review despite passing its own test suite. The practical takeaway: treat AI-generated tests as a first draft needing independent review. Verify 3 things. Auth tests include both success and failure cases. Validation tests include adversarial inputs like SQL fragments, script tags, and null bytes. And crypto operations use real functions, not mocks. Here's a quick reference of dangerous test patterns to detect during code review. Auth bypass flags. Search for test bypass auth, skip auth, or node env equals test inside middleware. The risk is that these bypasses may activate outside the test environment. Permissive auth mocks. Search for jest.mock, JSON web token, or mock resolved value, verified true. Token validation never runs, so tampered tokens are never rejected. Mocked crypto. Search for jest.mock bcrypt or mock resolved value true near password logic. Hash and compare are replaced with constants, making broken crypto invisible. Zeroed entropy. Search for buffer.alex160 as an IV or crypto.randombyte stubs. Predictable IVs break encryption, and if this leaks to production, your cryptography is compromised. Deleted security tests. Look for shrinking test files, commented out at blocks, exit, or test.skip on security cases. Injection and auth bypass cases are no longer verified. Run these searches during every code review that touches authentication or cryptographic code. When AI writes or modifies tests, review the diff with these 5 security-specific checks. Check 1. Look for removed lines. Run git diff on test files before committing. Deleted assertions and test cases are the most dangerous changes in a diff. Check 2. Search for bypass flags. Look for test bypass auth, skip auth, mock auth, or node env checks inside security code. A flag that weakens security based on an environment variable belongs outside production code entirely. Check 3. Search for permissive mocks. Look for mock resolved value true in files touching authentication, sessions, or authorization. A mock that always approves a check removes the security guarantee. Check 4. Verify negative cases exist. For every success test, there should be a failure test. Wrong passwords must be rejected. Expired tokens must fail. Check 5. Confirm crypto is not mocked. If bcrypt, argon2, or crypto appear in jest.mock calls in auth-related test files, investigate. The correct answer is almost always to use a lower work factor instead. Let's recap the key takeaways from this chapter. First, never add global auth bypass flags. Generate real test tokens using the same token generation code production uses. Second, never mock cryptographic functions. Reduce the work factor for speed instead of replacing the function with a constant. Third, treat test deletion as a potentially breaking change that requires documented justification. A deleted test is not cleanup. It is removing a safety net. Fourth, AI-generated tests are a first draft. Independently verify that the security properties you expect are actually being tested. These 3 patterns, disabled auth, mocked crypto, and deleted tests, are the most common ways that AI coding agents silently remove security guarantees from test suites. Watch for them in every code review.